calculate the delta H of reaction standard for the thermite reaction. Thermite. For those of you who don't know about thermite, it's a very, very, very powerful, very, well, we'll find out in a minute as far as the delta H, if it's positive or negative. The reaction is 2 moles of aluminum metal plus 1 mole of iron 3 oxide, okay, goes to aluminum oxide plus 2 moles of iron. So when you mix aluminum metal with iron oxide, you end up producing aluminum oxide, you end up releasing iron metal. Kind of amazing, actually. So now let's see what we've got. Let's go ahead and list some delta H of formation values. So the delta H of formation of aluminum equals 0. Aluminum is an element. Okay. The delta H of formation of Fe2O3 is equal to minus 826 kilojoules per mole. The delta H of formation of Al2O3 is equal to minus 1,676 kilojoules per mole. Wow, incredibly exothermic. And the delta H of formation for iron, well, iron is an element, 0. Good. So now let us take 1 mole times minus 1,676 kilojoules per mole plus 0. That's the aluminum plus the, wait, yes, that's right, the products. Aluminum plus the iron minus the reactants, which is 1 mole times negative 826 kilojoules per mole, which is the Fe2O3 plus 0. When we do this, we get minus 850 kilojoules. That's 850,000 joules. Exothermic is an understatement. Exothermic releases a hell of a lot of heat. In fact, it releases so much heat that the iron that comes out is not solid iron, it's actually liquid iron. The iron is melted. Okay, so let's see what we've got here. Do we need to do anything more? No, that's it. We found our delta H of the reaction is equal to minus 850 kilojoules. Notice delta H of reaction is in kilojoules, not kilojoules per mole. Kilojoules per mole is delta H of formation. That's what we used to get the delta H of the actual reaction.